So as I said, we are going to review some topics with the last class, then we're going to start new topics. And if you have any question, you can just unmute yourself and ask questions. And as we are learning statistics, so let's just take some look of last class.
ম্যাম ওই যে অ্যাসাইনমেন্টের বিষয় ছিল ম্যাম, অ্যাসাইনমেন্ট তো ম্যাম আর গুগল ক্লাসরুমের ওই যে পাসওয়ার্ডটা আরেকবার দিলে ভালো হয়, অনেকেই ম্যাম তখন জয়েন করেন।
গুগল ক্লাসরুম পাসওয়ার্ড 1 মিনিট, আমি এখন এটা শেয়ার করে দিচ্ছি চ্যাট বক্সে।
থ্যাংক ইউ ম্যাম।
So please join everyone, and you will submit the assignment through Google Classroom. So it will be show how much late you are, or you are on time or not. I think I will give a very few question. It will be you will be able to submit it within the time. And I have already make a group list. I'll share the group list with the questions. You will find your team members there. And I don't want to discuss anything about this anymore right now. Let's just start our class. If you have any question, we can take questions after class hours. So as I'm saying, I'm going to give you some review of last classes so you can catch up, and I'm sure you already forget everything. So let's just go through a review. We're learning skewness, moments, and kurtosis at the moments. And basically, skewness is the lack of symmetricity. I mean, if we consider the most peak point, if it is in the middle point, that it is symmetrical. And if it is not symmetrical, in that case, it is skewness. And the direction is either positive or negative side, considering the value of mean, mode, and median. As I said, median is not our considerable thing, only arithmetic mean and mode. Using these two, we can find that the skewness is symmetrical, or positively skewed, or negatively skewed. So we have used this definition of skewness. We have to find mean, mode, and we divided it, the subtraction, by standard deviation. So if it is greater than 0, then the distribution is positive, and if it is less than 0, then this distribution is negative. So that is the case of skewness. And after that, we have learned moments. Moments, I have said, it is actually a unification or union of all the measures, in this case mean, variance, skewness, central tendency, or etc. I mean, everything's variation is moments. So mainly 4 things. One thing is mean, the second thing is variance, the third thing is skewness, and the fourth thing is kurtosis. These 4 things combined moments. So there is only 4 moments, and moments, there are 2 types: raw moments and central moments. This is the definition of raw moments, and this is the formula for raw moments. As you said, for raw moments you will use a prime sign, and for central moments you will not have any prime sign. And the main definition looks similar, only the mean part is different. Here we are using for central moments we are using arithmetic mean, and for raw moments we are using a assumed mean. So we have learned up to the relationship of these 2 moments. First, we have learned that the first central moments is 0. So we always don't need to calculate the first central moments. First central moments will always be 0. And the second central moments, we have that it's equal to second row moments minus first row moments square. for the third central moment, we have found that third central moment is equal to third row moments minus 3 into 2 second row moments into first row moments plus 2 into first row moments cube. So this is the case for a third central moments. And then similarly for this is the formula for fourth central moments. And these first central moments, second central moments, third central moments, and fourth central moments, with the use of these raw moments, we are going to calculate these central moments. So always you need to memorize this definition. That was the till of last class before Eid vacation. So we are starting from this point. As I said, we need to calculate moments for various reason. So if you want to calculate moments, at first you need to memorize these central moments in the relationship with raw moments. Okay, for calculating the central moments, you will use this relationship, and so you need to find out the raw moments. And as we have raw moments definition, not here. Okay, that was the raw moments definition. You see, there was an assumed mean, and we don't know what is assumed mean could be. We can just take it. So we'll use a different formula for calculating this one. Okay, and it will be a little more, it will be more easy to use this formula to calculate. So we are going to use this formula instead of that formula. Basically, we're removing the last part. I mean, we're using this di here, di square for second, di cube for third, di4 for fourth raw moments. What is this d? I'll show it in the example. So at first you need to know that we are going to use these formulas. Actually, for first raw moments it is only di. For second row moments it is di square. For third row moments it is di cube, and for fourth row moment it is di4, and each case there is a h into h square. You see, for second it is square term in both case, for third it is cube term in both case, for fourth is fourth term for both case. So it is easy to remember. So we just need to calculate through this, and after finding the raw moments, you can use these raw moments to find the central moments. So I'm just showing it in, this is our example. I'll just show it in the board. And after showing it in the board, I'll also show it in the slide so that you can see the big file in the at the same line, since our board is not used enough. Okay. I think the board is a little bit clear. First, I will just draw the table, and then we are starting our class. that was the thing we have given for this problem. We have a profit and also their frequencies of their profit. These two lines were given. And xi is our mid value, as I said previously for every example. Whenever we have a range, we will take xi as a mid value. And we need to sum up the frequency for this because we always need division of n. So if it sum up is 100. At first, we need to know what is di. How can we get the di? It's actually your assumption. Okay. In most case, our total row is in even number. That is our five row. So in the middle or in the middle row, I mean whenever which is in the middle position, we'll take it as a 0. Okay, we'll take it as a 0, and then in the upper it will be -1, the lower it will be +1, -2, +2. We'll always use this formula to get the value of d. Whenever you need to find out d, in the middle position, you will consider that as 0, and in the upper, it will be -1, in the lower, it will be +1, -2, +2, and so on if you have more rows. And if it was the case of even rows, I mean, there is 6 rows. If it was 6 rows, you just consider one of the middle is 0, and then go on each side, you will get the result. So in the most case, this is the case. This is happened. We have always even numbers, so you don't need to worry about that. But even numbers rows came, you can just think one of it is 0, and then minus plus one will be extra. So what we need, as I showed in the I again showed in the formula, so it will be easy. Okay. That was our formula. So we need di square, di cube, di to the power 4 with fi multiplication with fi. Okay, so we need fi with multiply with di, fi with multiply with di square, fi with multiply with di cube, and so with 4 terms, since we have only 4 raw moments. So we use 1, 2, 3, and 4. This is for summation. This is for fi di. This is for fi di square, fi di whole cube, fi di whole 4. So first we will just multiply these two, and write down in this row. So if we multiply this -2 with 18, it will going to be -36. It is -20. It is 0. It is +22. It is +20. Okay. And after that, you need to sum up all of this. If you sum up all of this, it's going to be summation of fi di is equal to -14. And second case, at first you will square di, then multiply with 18. If we square this, it is going to be 4. 4 into 18, 72. 1 into 20, 20 is 0. 1 into 22, it is 22. 4 into 10 is 40. So it is going to be summation of fi di square is equal to 154. And for the third case, you just whole cube it and write down the result. It is going to be fi di whole cube is equal to -62. And for the last one, fi di to the power 4 is equal to 490. This is the completion of table. After completing this table, we are going to use the formula.
Miss,
Yes.
মিস FI/DI স্কয়ারের একদম লাস্ট রোটায় হচ্ছে 40 হবে না?
সরি, আমি 40 লিখতে যে 14 লিখে ফেলছি। থ্যাংক ইউ সো মাচ। So what was I saying? This is the completion of table. Okay, after completing this table, you just need to put down the. I'm just removing the first part. I'm writing here. You needed the find raw moments, and first raw moments was. You need to use this prime sign to show that it is actually a raw moments. The first raw moments formula was summation of Fi di divided by n into h. What is h? H is our step size, and always our step size was 10. In each row there is a step size with 10, so h is always 10. And summation of Fi and di I have found here is minus 14, and n was 100 and h was 10. So we have done finding first raw moments, just calculation, and we'll get it. It is minus 1.4. Similarly, for second raw moments, this is the formula. So for second raw moments, we need summation of Fi di square, and summation of Fi di square is here. It is 154. So this is the second raw moment. It's equal to 154. So this is the second raw moments. The first raw moments was, I'm writing down here so you can remember it. The first raw moments here was minus 1.4. Second raw moments is we have found 154. So third raw moments, what will be the third raw moments? Third raw moments, it has a power 3, and summation of Fi d cube is minus 62. If we just do it, it will be minus 620. So third raw moments is minus 620. Similarly, for fourth, case, we get 490. If we get the result, it is 49000. So we have found our 4 raw moments. Using these 4 raw moments, we can find our central moments using our relationship we have built up and we have memorized. So first raw moments, sorry, first central moments is always 0, no need to calculate. Second central moments, it's equal to second raw moments minus first raw moments square. So it's going to be 154 minus 1.4 whole square. It's equal to. So this is the second raw moment, and for third raw moment, sorry, third central moment is equal to third raw moment minus. So what is the third raw moment? Minus 620 minus 3 into 1.4 into. So after calculating this, it will be 21.313. This is the third row, third central moment. I'm going to remove this first one and write here the fourth central moments. Fourth central moments is equal to That was the formula. So just need to put down the value and we get what we need. We just calculate this to get 4732.7.51. So we get our central moments using the raw moments. Let's just see it in the slide again. So it will be clear if you didn't understand anything in the board. This was our problem given. An analysis of companies resulted here that that is the range of profits and their frequencies, I mean how many companies were profited in this range. So I have to calculate first for row movements and then convert the result into moments about the mean. If you if you have to find out raw moments, that means assumed mean, here directly you are not saying to find raw moments, but they used this assumed mean, moments about assumed mean, that means raw moments, and moments about the mean. So you have to find out the difference of raw moments and central moments. There could be different way to express. I can just give an example of finding raw moments and central moments, or I could write it as like this: moments about assumed mean and moments about the mean. Only mean means central and assumed mean means raw moments. So at first, this mid value here, we don't actually need it because we are not finding the mean. We are just using this D. So this mid value actually basically no need in this case, but since it is, you can just avoid this xi. There is no need for xi in this case. But if in this same problem there is another topic to find out mean, in that case you will need this xi. So what we have this range, and each range our step size is 10, and this is our frequency, and we consider di as a in the middle part it is 0, upward minus, lowered plus, in +1 +2 and so on, -1 -2 and so on if you had more rows. And this part I have already shown, say that just you need to, for the first one, it is for past raw moments. So you just need to multiply frequency with di. For second raw moments, you need to multiply frequency with di square. For third row moments, frequency with di whole cube. And for fourth raw moments, frequency with di to the power 4. After that, you need to sum up this to get the summation, and sum up the whole column to get the summation for each 4 case. This 4 case will give 4 raw moments. So this is our moments about assumed mean. I've just showed it in the board. You just have to put down the formula and the value you get in the table, and you will get the its value here. And after that, if you are using the central moments using the raw moments formula, it's easy to find out this result. So it's basically not so difficult. It's easy. You don't using this di, it becomes less complicated computation. But if you use mean, it will be a bigger computation. So that is a very different formula to find out these moments easily. So as I'm saying, this is the topics of moments. We're going further. Okay, further. Cardosis. Any questions?
Miss,
Okay, yes.
u1 equals 0 কেন বললো?
Okay.
পরে
This was actually relationship between central moments and raw moments. I need to show another slide for that. I have closed down it. In the last class, we have learned the relationship between raw moments and central moments. It's not, it's possible to forget since it was long time ago, before our Eid vacation. In this part, we have started our relationship from raw moments to central moments. And when we calculate first central moments, after calculation, it becomes 0. So it will always remain 0. You don't need to calculate it. And similarly, we get the second raw moments, second central moments, third central moments, but all the others are not 0. Only the first one is 0. If you just see the calculation here, you will see that using the fast central moments formula, you have where we have used fast central moments formula, and after putting the summation differently, and you get that it is actually giving a mean, and after here it is also another given mean, and the subtraction is mean with mean is equal to actually 0. So this is the formula. I think if you just saw the last class video, you will be cleared about it. So just see the last class video how we calculated this one.
মিস
Yes.
মিস আমার যদি মানে পরীক্ষার কোশ্চেনে এমন হয় যে কোনো একটা প্রশ্নের এ নাম্বারের অ্যান্সার আমি একটা টেবিল এঁকেছিলাম অ্যান্ড সেই টেবিল দিয়ে আমার বি অ্যান্সার করা যাবে, তাহলে কি আমি ওই টেবিলটা ইউজ করতে পারবো নাকি বি এর জন্য আবার টেবিল আঁকবো?
যদি একই প্রবলেমে হয়, আই মিন কোশ্চেন নাম্বার 6 এর এ তে যে টেবিল, বি তেও সেই টেবিল ইউজ করা সম্ভব, তো দ্যাটস পসিবল। বাট যেটা যদি হয় যে কোশ্চেন নাম্বার 6 এন্ড কোশ্চেন নাম্বার 8 এ, তাহলে আবার পসিবল না। ওকে,
জি মিস।
নরমালি একই টেবিল পসিবল শুধুমাত্র একটা কোশ্চেন সেটে হতে পারে। যেমন আমি এ তে দিলাম স্কিউনেস এন্ড কার্টোসিস মোমেন্টস বের করতে, আর বি তে দিলাম কার্টোসিস বের করতে, সেই ক্ষেত্রে সেম টেবিলই প্রয়োজন। সো সেই ক্ষেত্রে তো একবার বের করলেই হবে। Suppose after knowing the cartridges, you know that to learn cartridges we need to find out the moments. So whenever I'm going to tell you find out cartridges, and in the question B and in the question A, I'm asking you to find out the moments. So you already found out the moments and draw the table in the part A. So you don't need to do that for question B. You just need to take the value from question A and just directly put in the question B. And also check out the right side marks, how many marks it is carrying. If it is a low marks, you don't need to do hard work for a low marks, but if it is a high marks, so you need to show down your effort to get a high marks. So
Okay, miss.
Getting good marks is basically a technique and nothing else. What was I saying? I'm saying we're starting cartridges. For skewness, it was saying that it is symmetric or not symmetric. Actually, that is the part for skewness. And as I said, moments was the unification, and the last moment always referred as a some part is kurtosis. So what is kurtosis? If we show graphically, kurtosis actually peakness. How much peaked it is than the others. I mean, if you see these three figures, one is most peaked, and the another is in the middle of peakness, and the last one is a lower peaked. I mean, our the peaked point in which the direction of skewness is put, in that peak point, how much peaked is. If it is in the most upper peak, then it is known as leptokurtic. If it is in the green line, it is mesokurtic, and it is the purple line, it is platykurtic. Okay, this is actually the name. I'll give the condition for to be leptokurtic, mesokurtic, or platykurtic. There is the exact definition for that. So this is the normal curve. I mean, this green line, if it is just a normal curve and symmetric. And if it is peakness is more than this one, it is leptokurtic, and it is less than this one, So it is platycardic. So mesocardic is basically our normal curve, which is our standard size. We consider this is our standard size. And this has a definition of how to find. So let's just go through the finding this stroke problem. And as for this one, okay. This beta 1, it is actually known as measure of skewness, and for finding this, you see we have using central moments. Third central moments square divided by second central moments whole cube. Don't confuse the 2-3 part. It is third central moments in the upper part and second central moments in the lower part. So this is basically a measure of skewness, and always you will get thickness by your own. So you don't need to find out the how much it peaks. You just need to find out the measure of skewness, how much its direction is going to be. Since it is only showing a positive result, we know that beta 1 it's always going to be give a positive result, so it does not define whether it is negative or not positive. So we, instead of beta 1, we'll always use this gamma 1. It is known as Carl Pearson's skewness, and it is actually root beta 1. If we get negative fitness, we will use since root beta 1 means plus minus is always here for root sign. So for symmetrical, we will consider gamma 1 is equal to 0. For positive and negatively, we'll use, for negatively, we'll use gamma 1 is less than 0, and for positively, we'll use gamma 1 is greater than 0. So it is another way of defining our skewness. So in using this skewness, so we need to find out the kurtosis. How can we use the kurtosis? This is the direction we have found for the graph. It is using the skewness, and for kurtosis we are going to use beta 2. Beta 1 was for skewness, how much is skewed in which direction, and beta 2 is for kurtosis, and we are using this formula for beta 2, mu 2 divided by mu 4 divided by mu 2 square, and that means we need fourth central moment and second central moment. And in that case, if the result we get from this one is equal to 3, then our distribution is mesocardic. That means it is normal curve, normal standard curve, our standard position. If it is greater than 3, then it is peaked position. That means our red line. If it is less than 3, then it is in the lower part, I mean our platycardic. And this is another way for from the Carl Pearson's constant gamma 2. So it is actually you have to find out beta 2 first, then these 3 will determine whether it is positive, negative, or 0. If beta 2 is equal to 3, then it is 3 minus 3 is going to be 0, I mean mesocardic. And for beta 2 is greater than 3, it's going to be a positive value. For beta 2 is less than 3, it's going to be a negative value. So maximum time you will not find anything about skewness. Either you can ask finding beta 1 and beta 2, or finding gamma 1 and gamma 2 and then comment on your result. This is actually the comment. This 3 line and this line, these 2 line actually was the comment on the result. So basically, we maximum time we don't ask you to find the moments, skewness, or kurtosis. With maximum time we ask you to find beta 1 and beta 2, or gamma 1 and gamma 2. So that means if you want to find beta 1, beta 2, or gamma 1, gamma 2, you need to do all the process from the moments up to here. Clear about this? So this is the last part. I'm just showing a little bit in the graph in the slide. This is the last of this class, and also this this part is done. In the next class, we are starting probability theory. This fundamentals is already done. So this is if our normal standard curve. That means gamma is equal to 0 or beta 2 is equal to 3, and it is mesocardial. So whenever we have the result beta mesocardial. So when we have more than this peak line, if you crank it into the air like this. Is the video clear? Okay. So that is gamma 2 is greater than 0 and beta 2 is greater than 3. So it is leptocardic. If it is expanded, so it's like, so this is gamma 2 less than 0 and beta 2 is less than 0. It is tachycardia. So if you find any example to find this constant, either beta 2, gamma 2, at first you will ask find beta 1, beta 2, and comment on the result. Comment means you just need to show that it is positive or negative, so it is symmetric, how many is skewed and which direction it is skewed, and what is the thickness of cartosis. I mean, it is leptocardic, mesocardic, or platocardic. So see here for this example, calculate the first 4 moments about assumed mean and convert the result into moments about the mean. That's just the one part. And the second part was compute the value of gamma 1 and gamma 2. Gamma 1, gamma 2 is Carl Pearson's constant. We can also ask you to find Carl Pearson constant. So if you get that Carl Pearson constant, you have to find, that means gamma 1 and gamma 2, and comment on the result. So you just use your usual definition to find out the moments, and then just find out gamma 1 and gamma 2, which is beta 1 and beta 2. You have to find out beta 1 and beta 2, and then you will be able to say that the comment, the value of gamma 1 indicates here our gamma 1 is equal to 0.1693. So gamma 1 indicates that the distribution is slightly skewed to the right. Since it is a positive value, so it is slightly skewed and the direction was in the right direction, and it is not perfectly symmetrical. So it is skewed, so it will not be symmetrical. And gamma 2's value is minus 0.44, so it is less than 0. So the distribution is platycardic. The comment was very simple, but this comment hold marks at least 5% marks of the whole marks. Okay, if the whole process I have given 20 marks, then this marks, this comment, for this comment I'll give 5 marks. And to not write these comments, you will lose 5 marks. Clear, everyone?
Yes, miss.
So today's class is up to there. Any more questions?
ম্যাম অ্যাবাউট অ্যাজিউমড মিন আর অ্যাবাউট মিনের ডিফারেন্সটা যদি একটু বলতেন।
Assumed mean and let me just open the file. The difference is in the definition. Okay, whenever we're using assumed mean, we call it as a, sorry, whenever using the definition with the assumed mean means আমরা মিনটাকে assume করে নিচ্ছি আমরা তো arithmetic mean বের করা শিখেছি কি করি আমরা সবগুলো ভ্যালুকে sum up করে and after then we just divided with the total frequency, so we know how to find arithmetic mean. So if we use that arithmetic mean in the formula, that's going to be our central moments. Okay, it is centrally denoted, and it is actually this central moments is for presenting mean, variance, and skewness, and etc. And always we always we can find the mean if we have anything like not so clear about the data. So in that case we can use assumed mean. So in that assumed mean we know that moments as a raw moments. Okay, for raw moments there is no exact name such as mean, variance, etc. This is just raw moments. You can consider it as raw moments as a tool for central moments. We use these raw moments as a tool for central moments, and the difference is in the definition. Okay, assumed mean means we don't know exactly the mean, but we can assume that a mean would be like 30 or 40 or something like that. We can assume it, and after that we can compute this. So assumed mean is difficult to compute, so that we use the another definition for D to calculate, only for calculate. And if you write down the definition, you need to write down this assumed mean. And for central moments, that is exactly arithmetic mean. Okay, that means x bar. It is an arithmetic mean for sample, for any sample. I have given a lecture about this mean in the first class. Clear about the difference?
Yes, ma'am, clear.
Okay, thank you. If you don't have any more question, then our class will be stopped here. Any more questions? Okay, everyone, have fun, stay safe, and goodbye.